In this video, I want to demonstrate how to redo this code using incremental programming. So as you might recall, absolute programming means all my part coordinates come from the 0 here. Incremental is point to point. So as soon as I get to this point, this becomes my Cartesian coordinate, and I describe how to get to this point from here. And then when I'm here, my Cartesian coordinate now is here, and I need to describe how to get from here to here. So let's have a look at how to do this. First off, we need to position an absolute as we did here to get the cutter at the start. We should stay in absolute as we pick up our offset and move down here. And now we could change this to incremental. But before we do that, we never bothered to calculate the proper feed rate. So let's do that next. I'll just scroll up for a second. And the recommended feed per tooth for optimizing was 15 thou per tooth. And the average was 8. Now I'm going to start with 10 thou per tooth just because that makes it very easy to do in your head, and you'll see why in a second. So I'm going to open up the calculator and I'll clear this. Now to calculate the feed rate, it's the RPM, 7,500, times the number of flutes, which is 2, times my chip load, which is 0.01, and we get 150. So to do that in my head, I could have just dropped these two zeros and then multiplied this by 2. So I'm going to come down here and I'm going to add that feed rate of 150 inches a minute. And if I feel 10 thou per rev is too fast, this is a finished cut, so I can live with it. Or I could cut that in half easily and change that to 75. As it is a finished cut, I want a nice surface finish. And remember, a chip load of 5 thou per rev, which this now represents, equals roughly a 50 micro-inch surface finish. I'm going to come back here to the drawing. So now that we're here, I want to describe how to get from here to here using incremental coordinate system. So remember, this is now my 0. So I'm going to move in the x plus and in the y plus. So I'm going to come over here to where my code is, right here. And I'm going to delete the x and the y. It'll still be G02, but it's incremental. So I'm going to add a G91. It didn't have to go before the G02, that's just my preference. And then again, I want to ask myself, from here to here, how far is it in the x? Well, it's a full 90-degree sweep, so it's 0.2. Same thing in the y, it's 0.2. So I'm going to switch to incremental here, and I'm going to add x 0.2, y 0.2. Next, I want to see if that simulates properly, but I don't want this line in incremental, so I'm going to add a G90 here. And let's refresh the plot. And nothing's changed. This still has the proper arc. So we'll continue to convert these to incremental. I'll delete the G90. This is still a G03. Again, the radius won't change. So to go from here to here, we're sweeping through a full 90-degree arc. Here's now my Cartesian coordinate. Once again, we're going to go in the x plus and the y plus, and they'll equal the radius. So next, I want to program still G01, but incrementally from here to here. So there's no change in the x, but there is a change in the y. I go from the y at position 2 to the y at position 3. So the incremental is the difference between these, and it's in the y positive with my Cartesian coordinate here. So I'll open up the calculator, and I'll enter 1.299 minus 0.197 to get 1.102. So I'll come over here, that y is positive. I'll enter 1.102. Now, once again, we're going to go incremental from here to here. It's a full 90-degree arc. So the x and y will equal the radius. And when we put our Cartesian coordinate here, this is now in quadrant 3. So the x is negative and the y is positive. So I'll come down here and I'll cut and paste this. Then I'll make the x negative. And our last incremental move, once again, we'll put our Cartesian coordinates here. Cutter's in quadrant 3, so it's going to be an x negative, y positive, this radius, which is 0.2. So once again, I'm going to copy and paste this. Then add the negative sign. And I've now switched this to incremental programming. And that's why earlier I suggested we always put a G90 here, because we often switch between absolute and incremental. And let's just refresh our plot, and then I'll play it. So once again, the cut is fine, and we could program it in absolute coordinates or in incremental as we've just done now.